Alright, we're taking a look here at some arithmetic and geometric sequences with recursive equations, okay? So the fact here is that we are using recursive equations for both geometric and arithmetic, and it sounded like I just kind of repeated myself, which basically I did. So, the way we write a recursive equation, okay, remember it connects the outputs, okay, one output to the next. So the way we write it is kind of complex, okay? But the way to kind of think about it is like this. Okay, we want to get the next term here. Okay, in this sequence right here, this next term. Okay, well, how am I going to do that? Well, I need to know two things, don't I? I need to know the previous term, and then I need to know the growth, because I'm going to take that growth and I'm going to, use it on the previous term to do that. So, as we can see, we're adding 20 each time, aren't we? So I'm going to take that previous term, and I'm going to add 20 to it to get the next term. Okay, that's what I mean by connects outputs. Connects the previous output with the next output. Now, that's only half of a recursive equation, because we also need to know where it starts. Now, this part can be a little confusing, because we would look at this and say, oh, there's our starting term. That's actually our first term. When we're dealing with sequences, the first number we see is our first term. So to find the actual start, we need to go back to the zero term, right? This would be the second term, the third term, fourth term, and so on. So we have to go backwards to find that zero term, which we would subtract 20 and get negative 41 as our starting number. Okay? Now, in math, we don't like to write these words like this, do we? So instead, we're going to change how we do that. Instead of next term, we're going to put a sub n. Instead of previous term, we're going to do a sub n minus 1, okay? And then plus 20. So the idea here is that this n represents this number, okay? Say I want to find the fifth term. Well, to find the fifth term, right, I'm going to have to jump back a term. That's where the n minus 1 comes in, okay? And the start, because it's the zero term, becomes a sub 0. Okay, that 0 is represented right there. And those two equations make up the recursive equation, okay? We got to have the start, we got to have the growth. Now, the easy part about it is, on every single recursive equation, I'm going to write these first two parts. A sub 0 equals a sub n equals a sub n minus 1. A sub 0 equals a sub n equals a sub n minus 1. Okay, and I'm going to find the growth. So 8 to 11 to 14 to 17, I'd be adding 3. So we're adding 3. Okay, 23 to negative 77 to negative 177 to negative 277. I'm subtracting 100 as my growth. And I always put the growth with that a sub n equals a sub n minus 1. And we put the minus 4. Something to note here, it's always n minus 1, not n minus 100, not n plus 3, not n minus 4, n minus 1. And the growth goes on the back, as you can see. So I put them in a different color. Okay, now the start, we go backwards, right? Instead of adding 3, I subtract 3, and I start at 5. Instead of subtracting 4, I add 4, and I start at 6. Instead of subtracting 100, I add 100, and I start at 123. Okay? So that's all there is to it, okay? So is deciding if my questions are arithmetic. If they are, we add, subtract, add or subtract, I should say. Now, if they're geometric, like these examples, let's kind of zoom that in a little bit. Maybe not. There we go. Okay. The thing is, it's actually started out the same. Okay, to find that next term, that's what we're looking for, right? So we do the a sub n. What is it going to equal? Well, I need that previous term, which is a sub n minus 1, and then I'm going to apply the pattern to it. In this case, 3, 9, 27, 81, we're timesing by 3. So I times by 3. But I need to go back and find out where I start. So I go 3 divided by 3, which is 1. So our a sub 0 is 1. Okay, so just like before, we can write the formula out like this, regardless of whether it's arithmetic or geometric. We can write it like this, okay? And then we find the growth. Here, -1 to -5 to -125, or -25, then -125, times them by 5. Here, 54 to 18 to 6 to 2, we're dividing by 3. And I could put times 1/3 instead of divide by 3 if I really wanted to. -1 to 6 to -36 to positive 216. Okay, we're timesing by a negative number, and it's a -6. Then to go back, -1 divided by 5, -1/5. Now I could put -0.2, but just leave it as the fraction. Make life a little easier. Okay, 54 times 3 is 162. -1 divided by -6 is -1 over -6, which is 1/6. Okay, so regardless of whether it's geometric or arithmetic, we should notice really the only thing that changes is whether we're multiplying and dividing right here or adding and subtracting right here. Everything else is exactly the same. Okay, so those parts are always going to be the same. All right, so let's do some problems. And like I said, we're always going to have these parts. So really, if you wanted to, you could go on every single problem and write these out. And then go back and say, okay, now what's the growth? So -16 to -10 to -4 to 2, we are adding 6. -17 to -8 to 1 to 10, we're adding 9. 31 to 21 to 11 to 1, subtracting 10. 23 to 223 to 423, we are adding 200. Okay, so hopefully you see that growth and where that goes. And again, you can see that going backwards, -22, right? Going backwards to the 0 term, +41. Going backwards, -17 minus 9 would be -26. Going backwards, 23 minus 200 would be -177. Okay? So, that's all we got going on, guys. That's all there is. Once you find the start and the growth, boom, you got your problem. Okay? So, 12 to 17 to 22 to 27, we're adding 5. Going backwards, we'd be at 7. So a sub 0 equals 7. A sub n equals a sub n minus 1 plus 5. 9 to 11 to 13 to 15, definitely adding 2. Going backwards, we'd start at 7, so my 0 term is 7. To get my next term, I take my previous term and I add 2 to it. Okay, 11, 13 to 7 to 1 to -5. Looks like we are subtracting 6 each time. Going backwards, we'd add 6. So we'd start at 19. So a sub 0 equals 19. A sub n equals a sub n minus 1 minus 6. Okay, the thing to make sure you're doing is putting these as subscripts. Okay, because it's a sub 0. Do not write it a 0. Okay, that's wrong. Because then you're going to get confused about what is going on, especially with the minus 1. Okay, and that's when I start to see people doing stuff like this, thinking, oh, this is where I put my growth. That's not the case, because this is a subscript, so it goes below. Same with this, same with this. So I go a sub 0, a sub n, a sub n minus 1. And if you need to write it really small like that, the a is big and the n and n minus 1 and 0 small, do it. and we can see the growth of plus 3. Going backwards, we start at 5. I think we already did that one, didn't we, on an example? Got a freebie there, didn't you? 1 to negative 6 to negative 13 to negative 20, subtracting by 7. Going backwards, we'd start at 8 to subtract by 7 and get 1, so a sub 0 equals 8. A sub n equals a sub n minus 1, subtracting by 7. And the last problem on this front page, 36 to 34 to 32 to 30, subtracting by 2. Going backwards, we'd get to 38. A sub 0 equals 38. A sub n equals a sub n minus 1 minus 2. Okay? So if they're arithmetic, that's all we got to do. And really, if they're geometric, same idea. That's still all we got to do, right? So we look at these. Again, we could just start off on a bunch of problems and just type writing it in like this, couldn't we? Honestly, the hardest part, I think, with the recursive equations is just getting tired of writing them out. All right, so we find our growth, 1 to 3 to 9 to 27, times them by 3. Negative to positive to negative to positive, times them by a negative number, 2 to 12 to 72, definitely it's negative 6. Negative 1 to 5 to negative 25, again, times them by a negative number, and it's going to be 5, right? Because 1 times 5 is 5. 1 times 2 times negative 4 to negative 8. Okay, definitely times by a negative number. And it's going to be 2. Make sure we're not putting an x there, okay, to mean times. We got to get out of that habit if you're still doing it, okay? Got to get out of that habit. 22, 4 to 20 to 100 to 500. Times them by 5. There's our growth. 3 to 12 to 48 to 192. Times them by 4. There's our growth. Now, if you're not sure what kind of sequence it is, okay, I would start out, let's use 19 as maybe an example. Okay, and look at your first couple of numbers, okay? You could say, if you're not sure where to go, you could say, okay, what's 3 minus 1? Take that second one and subtract the first one. That would give me 2, positive 2. So I'm adding 2. Does that work? Okay, it doesn't. So then you could try multiplication and go, okay, what's 3 divided by 1? Well, that's 3. So I'm timesing by 3. Times by 3, and we see that that's the pattern. So if you're not sure, you can always kind of do the opposite of what you think it may be and check that out. Which is kind of what we have to do going backwards here. So 1 divided by 3 is going to be 1 over 3. You could put 0.3 repeated, but just keep the fraction, make life easier. Okay, 3 going backwards, instead of times 4, it's divided by 4, so we get 3/4, or 0.75. Negative 2 going backwards, negative 2 divided by negative 6 can reduce to positive 1 over 3, because a negative over negative is a positive. 2 over 6 is 1/3. 4 going backwards, divided by 5 is 4/5. Negative 1 going backwards, dividing by negative 5 is negative 1 over negative 5, so positive 1/5. Negative 2 going backwards, or negative 1 divided by negative 2 is a positive 1/2. Okay, so not too bad, right, guys? Okay, so that's really all we got going on here. So find the growth. 125 to 25 to 5 to 1. Here we're dividing by 5. Going backwards, I'd times by 5. We'd get 625. So I start at 625. To get my next term, I take the previous term and I divide by 5. Or I could write it as times 1/5. Okay, either way works. This one will be helpful when we get to explicit, so maybe a good idea to kind of start thinking in that terms. 240 to 120 to 60 to 30, definitely dividing by 2 or timesing by 1/2. Going backwards, we double it to 480. So 480 is my a sub 0, and a sub n equals a sub n minus 1 divided by 2. Last two, 162 to 54, may not make much sense. Neither 54 to 18, but 18 to 6, I definitely know I'm dividing by 3 there. Okay, so going backwards, I'd times by 3, and I would get 6, 18, 286. That doesn't seem right. 4, duh. 3 times 1 is 3, plus 1 is 4. 486. So 486 for a sub 0, and a sub n equals a sub n minus 1 divided by 3, or times 1/3. Okay, last one, 28. 3 times what to get to 6, to get to 12, to get to 24? Definitely timesing by 2. Going backwards, be 3 divided by 2, or 1.5. So a sub 0 equals 1.5. A sub n equals a sub n minus 1 times 2. So hopefully we realize no matter what we do with the recursive, it's going to be a sub 0 equals our 0-term number, right? Then a sub n equals a sub n minus 1, and we either add the growth, subtract the growth if it's arithmetic, multiply the growth, or divide the growth if it's geometric. Okay, remember, if it's these two, it's the common difference. These two, common ratio. We could also call them rate of change. There's a lot of different names for it. But yeah, guys, so that's pretty much all we got.